Hi everybody. Today we are going to be talking about lesson 4.4, rational numbers. All right, we're going to take a look. You should be in your book on page 215. We are going to be pausing along the lesson today so that you can complete activities. So make sure that you are following along with your book. All right, here we go. So, like I said, we're on page 215. So natural numbers, here we go. Recall that natural numbers are from the set 1, 2, 3, 4, where the dot, dot, dot means continue without end. The set of whole numbers includes a set of natural numbers and 0. Integers are any numbers from this set, right? So positives and negatives, continuing without end. Any numbers that can be written as a fraction, as in a over b, like the example 2/3 or 1/4, where a and b are integers and b does not equal 0, is a rational number. So rational numbers can be represented as a point on the number line. So basically, anything that's a rational number can be represented as a fraction. So when we take a look at this diagram here, if we start right in the center, natural numbers are any positive numbers. Whole numbers include anything including 0 that's positive. Integers include any whole numbers altogether. And rational numbers are numbers that can be written as a fraction. A terminating fraction, I should say. Okay, so, or they have a pattern to them. Terminating or repeating decimals work, but if you have a number like pi, for example, if you look up on the wall in my classroom along the ceiling, that is called an irrational number because it doesn't have a pattern to it and it doesn't end. So rational numbers, remember, can be written as a fraction. So we can graph rational numbers on a number line. There are sets of rational numbers that we can graph on horizontal or vertical number lines. A set of rational numbers is written using braces, such as here, right? 2.25 or 2 and 25 hundredths, negative 1 and 3/4 or 0. To graph a rational number on a number line, we place a dot at its location, much like what we did when we were graphing integers. All right, turning the page to page 216. We're going to graph this set of rational numbers. Now, we have a variety of fractions and decimals, so it's important to understand the value of both. We need to know what negative 1/5 is as a decimal or negative 7/10 as a fraction. Either way, you need to find a way to equate those values to be the same. So find the integer boundaries of the set. The values in the set lie between the integers blank and blank. So that means what's the highest number and what's the lowest number? So if we look at this, the lowest number, the least value, would be a negative 1.8. Okay, so we could say that where we could start our number line would be negative 2. The highest value we have is 2 3/5. So the biggest whole number after 2 3/5 would be 3. So we could say that all of these integers lie between negative 2 and 3 for all these rational numbers. Then we go ahead and graph that. To graph the set, it might be helpful to rewrite the fraction and mixed numbers as decimals in order to find the locations on the number line. So remember, if we are changing a fraction to a decimal, you can do this a couple of different ways. You can take the numerator and divide by the denominator, or you can get this up out of tenths. Either way works. Well, if we were going to get this up out of tenths, I'll start by writing that as a fraction, and then we can convert it to a decimal. Tenths, that would be times 2. So the 1 times 2 is 2. And then we change it to a decimal. A decimal place would be 1 decimal for tenths. So we'd have a negative 0.2. Okay, so I'll just rewrite this a little more clearly. Like I said, a negative 0.2. The same thing goes here. Our whole number stays the same. To get fifths out of tenths, right, we would multiply by 2, so we get 6/10. But 6/10 as a decimal is just one decimal place, so it would be 2.6. Then we can graph those on a number line. If I were to count the values between 0 and 1, it would tell us what each tick mark is worth. So we have 1, 2, 3, 4, 5. So each line is worth 1/5 or 2/10. So going below 0, because we have a negative 1/5, I would put that here. A negative 7/10 would be between these two, right? Negative 6/10 and negative 8/10. This would be negative 1 and 8/10. And then we would graph 2 and 3/5 up here. So now we are able to order these rational numbers. All right, let's move along now to checking or doing our check activity down at the bottom here. We're going to graph this set of rational numbers on the number line. What I would like you to do at this moment is to pause the video and see what you can find for where each of these rational numbers would be graphed. So go ahead and pause here. Now, you can resume. You should resume after you've finished. And what you would find to where each of these values would go, we're going to graph them on here. So negative 1 and 7/10. Let's count again. 1, 2, 3, 4, 5. So each of these are worth 5/10, or I'm sorry, 2/10, 1/10, 2/10. So here's negative 1, negative 1 and 2/10, negative 1 and 4/10, negative 1 and 6/10. So negative 1 and 7/10 would go right here. 1.5, so 1.5, right? Here's 1. I'm going to go halfway between 1 and 2 to put my 1 and 5/10. 2/5. Well, each line we said was worth 1/5, so 2/5 would go here. And negative 6/10, negative 2/10, negative 4/10, negative 6/10 would go here. How did you do? All right, moving along, page 217. Let's talk about absolute value of rational numbers. Once again, absolute value is the distance between a number and 0 on a number line. The same thing applies when we talk about rational numbers as it did with integers. So for example, if I was finding the absolute value of 2.5, right, 2 and 5/10, the value would be 2 and 5/10. The absolute value of negative 2 and 5/10 is also 2 and 5/10 because it's that far away from 0. So moving on to example 2. Finding absolute value of rational numbers. The lowest point in a certain cave has an elevation of negative 53.4 meters. So 53.4 meters below sea level. If the cave entrance has an elevation of 0 meters, evaluate negative 53.4 to determine the number of meters a hiker would descend to reach the lowest point. So first we graph it. Here it is on our number line. How many units away is it from 0? Well, we're finding the absolute value. It is 53.4 meters. So we know then that the hiker descended 53.4 meters. That's how far that hiker walked. Let's go ahead and do the check. I'll read the problem and then I'll have you pause and solve it on your own, and then you can check with me. The Miller family is having an in-ground pool installed. The deepest point will be negative 9.75 feet below ground. If the ground has an elevation of 0 feet, evaluate the absolute value of negative 9.75 to determine the depth of the pool. Go ahead and pause here. Write your answer. So the absolute value of negative 9.75 is 9.75. It is 9.75 feet below ground. So that's how far it would be that they would have to dig down. All right, moving along now to the next page. We're on page 218. We're going to compare rational numbers now. So to compare two rational numbers, you can compare the signs as well as the magnitude or size of the numbers. If the signs are different, the positive rational number will always be greater than the negative rational number. And that's the same as when we talked about integers. Positives will always be greater than negatives. So when we look at these two numbers, we immediately see that the signs are different, so we know that 1.5 is greater. If the signs of two rational numbers are the same, we can graph them and figure out which one is furthest to the right, much like what we did with the integers. So if I'm comparing negative 1.5 and negative 1.2, I put both of them on the number line, and I can easily see that negative 1.2 is further to the right, so that would have the greater value. All right, let's take a look at example 3. Now, here we have negative 0.51 and negative 12/25. Now, the problem with comparing numbers when they look like this is that they are not in the same format. We need to get both of them either to a decimal or to a fraction to make it easy. Now, if I choose to make them both fractions, I'd have a couple extra steps, okay? Because I would have to then change it to a fraction and then get it to a common denominator, so multiple steps. Whereas I could just easily convert this to a decimal, okay? The reason is I know that 25 is a factor of 100, and we have a hundredths place, right? It's 2 decimal places. Okay, so to get 25 to 100, right, 2 decimal places, I'd multiply by 4. So I'm going to take my 12 and multiply by 4, and we would get 48, right, 48. So we have a negative 0.48 as the value of negative 12/25. So knowing that, we can compare negative 0.51 and negative 0.48. Which one has the greater value? Well, remember when we're dealing with negative numbers, the bigger the number, the smaller it actually is. So the greater of the two values would be this, which is that negative 12/25. We can graph it on our line right there. So we would then know that this would be the correct inequality statement. Let's go ahead and do the same thing with this problem here. I'm going to convert negative 3/8 to a decimal and then compare. Now, the other way to convert a fraction to a decimal is to take the numerator and divide by the denominator. So we're going to add a decimal here and a couple of zeros. I'm actually going to add 3 zeros here. 8 can't go into 3, so I put a 0. 8 can go into 30 3 times. It's 24. 8 can go into 60 7 times with 56. And 60 minus 56 is 4, and we have 40. Okay, so we know then the 8 goes into 40 5 times. So go ahead now. You know that this would be a negative 0.375. Take a moment, pause, write your inequality statement. Which one is greater? All right, so negative 3/8, remember, is this negative 0.375. And we have negative 0.413. We would know that negative 3/8 is actually greater than negative 0.413. So our inequality statement should look like that. All right, turning the page. Let's talk about ordering rational numbers now. To order rational numbers, we follow these steps. Write each number in the same form. So like what we had done when we were comparing, getting either both to fractions or both to decimals. Since there may be different denominators in the fractions, it's easier to write all the numbers as decimals. Try to get everything into decimals. make your life so much easier. We use the signs of the numbers, place value, or a number line to compare the numbers. Then order the values from least to greatest or greatest to least, depending on what the directions say. So to order this set of numbers, 1/4, negative 0.375, negative 17/50, and 3/10, graph each number on the number line. The least value is farthest to the left, and the greatest value is farthest to the right. So here we can see, to order the numbers from least to greatest, we would say negative 0.375, negative 17/50, 1/4, and 3/10. Greatest to least, we would just reverse the order. We separate them with commas, and that is how we do it. Simple as that. Now, if we're going to order this set in example 4, we need to start by writing each of these as a decimal. Now remember, we can get these up out of hundredths, okay, very easily. This is already a decimal. We don't have to do anything with this. We can now make this a decimal. So we keep our whole number. Hundredths, remember, is 2 decimal places. We can get 25 up to 100 by multiplying by 4. 8, right? And this one, we can easily multiply by 10 to get up to 100, right? So negative 2.10. Now I could just say 1, right? But all these others have 2 decimal places, and to help us get our minds organized, right, and not make mistakes, we annex a 0 here to easily compare. Sometimes if we don't have that 0 there and we only have 1 decimal place, you might think that that's the smallest because it only has 2 digits versus these that have 3. So make sure to add that 0 on there. If you're getting these out of hundredths, get this one out of hundredths as well. Just help keep your mind in order. Then we would go ahead and graph these rational numbers and find that the order goes like this. All right, at this time I'd like you to pause once again and do your check here. You're going to order this set from least to greatest. So when you've resumed here, you should see that this would be a value of 2.1, right? 2 and 1/10. Remember, we can add zeros on here to keep them all similar. 1/5, negative 2 and 1/5 would be negative 2.20. Okay, and now we can order these from least to greatest. I know then that negative 2 and 1/5 would actually go first because I'm going to convert it back to its original format. Then I would do negative 2.1, 2.1, and 2.12. This is the correct order from least to greatest. All right, moving on now to your apply question. It says, Mr. Plum's agriculture class is growing pumpkins under different conditions. The table shows the change in weight for each student's pumpkin in relation to the weight of the pumpkin with the current class record. Which student's pumpkins broke the record? Which student's pumpkins was closest to the record? So at this point, I am going to have you stop here and you are going to do the apply question. You can work together in small groups if you're here in class. If you're watching this at home, I do challenge you to try it on your own at home and email me the answer. All right. That's all that I have for you guys today. I hope that you have a great day. Please let me know if you have any questions, and I will get back to you as soon as possible. All right. Thank you.